Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're setting up and solving equations in context. Now this is a really exciting video because we've done a lot of work in algebra and solving equations, and this is the first time really where we can start seeing the purpose and the use of that. Algebra is going to be really good for us to solve some problems that otherwise we'd struggle with. So let's start. Just before we get going, I want to just touch up on a few skills I need you to know from prior learning. If I showed you something like this, question 1, what is something like this? Question 2, what would you usually be asked to do with something like this? Well, this is an algebraic expression, and usually you would be asked to simplify something like this. And if you simplified that, you would collect your x's. I've got an x there, add another x, and I've got a positive 2 here and a positive 4 here, and I would say this is identical therefore to 3x add 6. Okay? And you're used to doing things like that. Now suppose I showed you something very similar, but I told you to solve this. Tell me what you think you'd do as your first step. Well, hopefully you do just as you did above. You collect like terms for the expression on the left hand side, and you would collect like terms, so it said 3x add 6 is equal to 792, and then we'd solve the equation as we're used to. We want x on its own on the left hand side, so we're going to undo that add 6 by subtracting 6 from both sides, and we get ourselves 3x is therefore equal to 792 take away 6, which is going to be 786, and therefore to get x on its own we divide both sides by 3, and we would get ourselves that x is therefore 786 divided by 3. Probably need to go off here and do some short division to get that right. 3 goes into 7 twice, remainder 1. 3 goes into 18 6 times, 3 goes into 6 twice. So the answer would be x is 262. And we're going to have to solve equations like this from our context. So just be ready to do this sort of step. Step 1, collect like terms, and then afterwards solve like we're used to. Okay, time to try some questions. Imagine we're told the sum of 3 consecutive even numbers is 792. Find the 3 numbers. Now, in order to do this, we need to introduce some algebra. Firstly, it's telling us the sum of 3 consecutive even numbers. Now, what does consecutive mean? Consecutive means one after another. Now, we don't know what these numbers are. We're asked to find the 3 numbers. But what could we call the first number? What do you think would be a good name for the first number? Well, why don't we call the first number x? What is the number? What would be the next even number? Imagine that was even. That was like a number we don't know. Say it was like 8. The next one would be 2 more than it, wouldn't it? So the second even number after it would be x add 2. And the next one after that would be x add 2, add another 2, which would be x add 4. And it says the sum of these 3 numbers, so if we add these 3 numbers up, we get ourselves 792. Look familiar? That's what we did on the last slide, isn't it? That there is an x, add another x, and we've got a plus 2 and a positive 4 here. So we're going to get ourselves 3x add 6 is equal to 792. I solved that at the start of the video, and I got myself, I took away 6 first, didn't I, off both sides, and I would get 3x again like I did before. 3x is equal to 786. Then I divided both sides by 3, and I got myself therefore that x was equal to 262. Now that's not what the question asked. The question said find the 3 numbers. Now x was my first number, so the first even was 262. The one after it is going to be 2 more than that, which is 264, and the one after that is another 2 after it, which is going to be 266. Indeed, if you tried adding those numbers up, you would get 792. They're the 3 consecutive evens that sum to 792. and we used algebra to solve what seemingly is a really hard question. It would be dead hard to just guess those numbers. Right, let's try another one. See if you can use algebra to solve this. It tells us the sum of three numbers is 56. It says the second number is 3 times the first. So that's the first number. The second number is 3 times the first. And it tells us the third is 14 less than the second. Find the numbers. Right. Which one should we name? Let's name the first number. Why not always start with the first number? Let's give it a name. Let's call it x. The second number is 3 times the first. So the second number is like the first number but 3 times it. So the expression for that is 3x. The third number is 14 less than the second. Well, the second is 3x, so this one must be 3x subtract 14. It tells us the sum of these is 56. Find the numbers. So let's write an equation. The first number, x, add the second number, 3x, add the third number, 3x subtract 14, has got to equal the sum, which we're told is 56. Let's collect like terms. I have an x, add a 3x is 4x, add another 3x is 7x. So I'm going to have myself that 7x subtract 14 is equal to 56. This is a two-step equation I can solve. Undo that subtract 14 by adding 14 to both sides, and I get myself that 7x is therefore equal to 70, and I divide both sides by 7 to get myself that x is equal to 10. But the question didn't ask x, it said find the numbers. Well, the first number, I gave it the name x. So the first number's 10. The next number was 3 lots of the first number, 3 times 10, which is 30. And the next one was 14 less than the second. 14 less than this is 16. And if indeed you add them up, you do get 56. And we're done. Next, pause the video, see if you can use algebra to solve this. Right, it tells us Colin is 7 years older than Henry. It tells us that Paul is 13 years younger than Henry. If the total of their ages is 80, it says 80 years. How old is the youngest of them? Okay, what should we call one of the ages? Well, Colin is 3 years older than Henry. Paul is 13 years younger than Henry. Henry seems to be the one from which the others are either older or younger. So let's give Henry's age a name. Let's call it X. Colin is 3 years older than Henry, so Colin must be X, add 3 years old. And Paul is 13 years younger than Henry, so Paul must be X, subtract 13 years old. It says the total of their ages is 80. So let's take Henry's age, which is x. Let's then take Colin's age and add it together, which is x add 3. And let's take Paul's age, which is x subtract 13. It said the total is 80, so if you add them up, you get 80. Collecting like terms, we have x, add another x is 3x. And we have positive 3, take away 13 is negative 10. So what would we have? We'd have that 3x subtract 10 is equal to 80. We'd undo that, subtract 10 by adding 10 to both sides, and we get ourselves that 3x is therefore 90, and we divide both sides by 3, and we'd get ourselves that x is therefore 30. Now it said which is the youngest of them. Now be careful to answer the question here. Henry is therefore 30, Colin is therefore 33, and Paul is therefore 30 take away 13, which is actually 17 years old. Lucky Paul's still a teenager. So the youngest, we have to actually answer the question, is Paul, who is 17. And we're done. Pause the video and see if you could try this one. There is a number that if you triple it and subtract 20, you get the same as when you double it and add 4. What's the number? Well, let's call the number x. Okay? And it says if you triple it and subtract 20, so if you have x and you triple it and subtract 20, it says it's the same as when you double it, so if you had x and you doubled it and added 4. And it says the two would be the same. So the equation we could write down is that 3x subtract 20 must be equal to 2x add 4. Now we want all the x's on the same side, so I'm going to subtract 2x from both sides, and to undo that take away 20, I'm going to add 20 to both sides at the same time. And therefore we get 3x take away 2x is simply 1x. X is therefore equal to 24. And do try it, triple 24 and take away 20, you get the same as when you double 24 and add 4, and we're done. And that's it for this particular video. There are a couple of extra examples on the PDF that link this skill to something we're going to do later in geometry. So do check out the PDF in order to practice those as well, but they're not going to be in this video. Anyway, that's it. Thanks for watching.